Hello, today we'll talk about hydraulic system. And the hydraulic system is actually quite used in a lot of application. For example, I'm drawing something quick one, and I might have a piston right here, right? Have a force acting on here, F1, and then it's going to transfer to that power, hydraulic power, to something here, F2. So normal application you see, for example, when you the jack to lift the car, that's a hydraulic system. And another one, for example, it's like your car. When you press your car brake pedal, and then the pressure is created in the brake master cylinder, and then it's going to be transmitted through this hydraulic fluid from this master cylinder to the wheel cylinder. So where piston in the wheel cylinder will push the brake shoes against the brake drum. So those are a lot of hydraulic system in the application. What happens in the system is when a force is applied at one point, it's going to creating the pressure, right? For example, at this point 1, it's going to create an F1 divided by area. The pressure is applied at this point, and it's going to be transmitting through the fluid to another point, so it's going to have the same pressure here, F2 over area 2. So one principle we need to know is in the hydraulic system, the pressure is nearly constant. That's pressure is constant. So yeah, in other words, P1 is going to be equal to P2. So knowing that, we can see at F position number 1, when you apply a force at this cross section A1, that's going to be the same pressure at the end point F2 divided by A2. Okay, so knowing that, we can solve an example here. If this is a hydraulic system and we have a 2-cylinder, obviously this cylinder is going to be smaller cross section and this one is greater section. And let's see if this has a radius of 5 centimeters. So if it's a circular cross section, and here is 15 centimeters. And then imagine if you have a mass on here, let's see use the force. If the force is, let's say 100 grams applied on here, and then they want you to see what's going to be the force on here, F2 here. Okay, so how do we solve that? We're gonna use this concept. If it's a hydraulic system, the pressure is constant. So F1 divided by A1 is gonna be equal to F2 divided by A2. And before we put our numbers in, I want to actually derive this equation first. If this is a circular cross section, then my cross section is going to be pi r1 square, and F2 will be pi r2 square. Then we can cancel out the pi. What we're trying to solve is F2. So cross multiply, F2 will be equal to F1 times r2 square divided by r1 square. Okay, then F2 will be F1 R2 R1 ratio, the radius ratio square. That comes handy if, again, assumption this is a cross-section area, it's a circle. Then we know at other end, F2, it's going to be the pressure ratio square times that much fold higher. So for this example, we have F2 will be equal to F1. R2 is greater radius, 15. R1 is 5. So the ratio is 3. And then, however, it's square, so that becomes 9. So imagine that's how the lift, the car jack works, right? And, when you're pushing with a smaller amount, however, it's increased, for this example, 9-fold. So then F2 is going to be 9 times F1. F1 is 100 Newton. So the one you are lifting, the load you are lifting, become 900 Newton. That's hydraulic system. Okay, so that will be a quick, that wraps up a quick example of hydraulic system. All right, I think that will be it. I will see you next time. Bye.